All right, now in this section, we're going to be going into interacting with the game. So this is not actually as trivial as I thought it was going to be originally. Um, when it came to it, I thought, there's Python packages to press keys, there's Python packages to read key presses. This is going to be easy peasy. Now, before we do anything regarding key presses, I do want to mention one more setup thing. All of this, I'm going to make this go away. I'm going to bring it up. You'll notice that my screen is smaller now, and that's because in order to make all this easier, reduce the size, I'm playing on windowed mode, 920 by 1080, when my default is full screen, 2560 by 1440. That's sort of what I was playing at before, and that would be the full screen of my laptop. And so you can see that this just makes it easier to alt tab between things, to have a code block, or to have my command prompt up at the same time. And also it's just a smaller system, so we don't have the downscaling process is much smaller. So overall, that's just what we're running at. And the thing to note is all of this is very somewhat precise. When we get into the measuring the health bar of the boss, that's going to be the most precise thing. So what you want to do is you want to line up, take your windowed mode and line it up to the top left of your computer screen, because what you're going to see is that we screen cap. The way we do this is we take basically a screenshot of your screen from a certain area. So we're not actually keeping track of the application Elden Ring, we're just keeping track of that area of your screen. And so lining it up top left, you want, so the little header, the white part that says Elden Ring at the top, you want that to be in the top left. So just if you fit it in the top left, it should work. If your computer has different resolutions, if you have a higher quality or lower quality screen, this might change. I don't know exactly how that works. So my default is the 2056 and 244 hertz is my default resolution and refresh rate. I don't know if things change or how that affects it, to be entirely honest. So yeah, so that's the first thing to note. The second thing I want to make sure to mention is that we're going to be rebinding some keys. So obviously, normally I play on mouse and keyboard. You can see this is my key bindings right here, and you'll notice something immediately, and that is I've actually already rebound the keys. So taking mouse input is something that is probably definitely possible, but I didn't really feel like figuring out. Taking mouse movement input is probably harder than taking left and right clicks, but that's fine. We're just going to work it all internally. So we have UIOP as these are the only ones that we care about. So we only actually have a subset of actions, 11 actions. So we have the movement, the 4 movements, plus space for rolling, plus R for health potions, plus these 4 takes us to 10. And then the one other one is, I'm blanking on it right now, UIOP, F for jumping. So those are our 11 movements. There's nothing else. So there's no spirit summons. There's no switching between potions. All of that potentially can be incorporated later. We're trying to get sort of the proof of concept down, and so we just need those things. You can definitely be Margaret with just those things. And surprisingly, actually, I found parrying substantially easier when it was on P than when I shift right clicked. So that, if you're playing on mouse and keyboard, maybe try it out. I found it a lot more reliable and easy to hit those parries. So anyway, those are the key ingredients. So I'm going to continue exactly from where we left off. And for now, I'm going to jump back into the code. And I'll just leave this guy. Yeah, you can see him. So this is now what we're sort of starting out. This is the starting point, if you will. And so you can see right now this is U, I, O, and P. And pressing one button for parry is actually really nice. Okay. Anyway, I'll make this disappear now and we'll go back to the code. So the first thing we need to do, right, is have a way for our AI to actually be able to see the game. So we have some standard imports. But the two things I want to highlight are, I don't even think keyboard is necessary. I should probably get rid of that so people don't get confused. The things I want to highlight are MSS, which is what we're using to screen cap. The reason we're using MSS is simply I was looking for ways to do this, and MSS was really fast. So you can easily get at least like 30 frames per second, I found, using MSS in Screenshot. I'll be sure to link it below, of course. It stands for multiple screenshots, in case you're wondering what MSS stands for. And so I found it to be really fast and really easy to work with. I don't know if it's the best solution, but I think it works fine. The other thing of note, CV2, of course, is the image library, is the Win32 API. So this is a little complicated. The reason for this is, in order to read inputs from the game, we can't just see what buttons are being pressed. And the reason is, this is actually a surprisingly difficult task, and it has to do as well with how the game sort of receives the inputs, and how, if we're doing multiple inputs at the same time, all of that works. So basically, the best way and the fastest way to get the direct keyboard inputs are is this Win32 API, which is sort of like the direct access to what's going on in Windows. So Python has sort of the low levels operating system access. This is kind of tricky to install. I'll link the installation process below. And the reason it's kind of tricky to install, just moving so many tabs that I have open around, is because so you install it from, you can do a pip install. However, if you have any sort of virtual environments, like of course I'm sure many of you do, I do as well, it's going to give you a specified procedure could not be found, or entry point not found error. And so that's on the pip website that of course I'll link. And so what you want to do is you want to clone the repo and then execute the Python scripts pywin32 post install.py, which is outlined once again in the pip documentation. But just note that you do have to sort of clone the repo and then do that process. So with all of that established, now we can actually get into how we're going to screen cap this game. And the way we do it is pretty straightforward. So we have all of our possible values here. So the movements, jump, all of this stuff. And this is just creating basically the indices. So mapping characters to numbers, basically. W is 0, A is 1, etc., etc. But we use a dictionary so we can actually just index it, and it's very easy. We have this. This is some code I actually took from Syntex's original thing, where this is how you interact with the Win API. You get the key state by looking at the ASCII representation of it. Space key is 0, so we just add a special character basically for that. So every time we check keys, we're going to get all the keys in this. We're going to go through all these keys basically and see if it's being pressed. And this is insanely fast because it's operating at this low level. This is tracking our FPS. That's all it's doing is. This is also bad coding practices, I just realized, because we're relying on scoping for init to be defined. In fact, I don't even think it is defined. Oh, it is defined there. Okay, well, that would have been, this is probably not something you should do. We should probably call and have it be but that's unimportant. And then this maps the keys to the array, basically. So this maps it to a uint8 array. This is probably, you could probably do binary or something to be like hyper efficient. But uint8 scales pretty well. So now this is where we get into the main code of actually screen capping things. So we're specifying where we want to save our data, right? Because this is us playing the game. We're recording our keys so that we can, right? If we're playing the game, it records our keys. So this is just telling us the path. And this is saying if we already have some folders in there of that name, because I save it in batches. So That way, if anything goes wrong or we want to cancel, we don't lose that entire run. So it saves it in batches, and so each one in a different folder, or each one with a different name. So yeah, we save them in batches of 100 images. So this is our every time we save our key inputs. So we have 11 key inputs. We have our images, which we downscale to 244 by 138. And these are, of course, integers as well. Then we have our rewards, which we'll talk about in a little bit. That's not something we utilize at all currently, but that's basically reading the health bar of Margit. These are the values that we use to, actually, I don't know where, these are the values we use to read the health bar. These values right here are used to define the health bar. Then we have a little delay so that I can start the command Alt-Tab into the game and be ready. Now, this is how we take our screenshots. We do mss.mss, and then we go through and we say, okay, we can keyboard interrupt this at any time. We get the top left of the screen using this. These are the dimensions that we want to capture. We're capturing this in a NumPy array. We're converting this. I guess I'll skip to the health bar. So this is zooming in on the health bar. And what this is doing is this reads the line basically of how much health he has. And so if the count is 0, so if this is the first time we're doing this, then that's his maximum health. And basically we're saying the reward in some reinforcement learning context would be the amount of health that you've done, or the damage that you did. So this is set to a negative. So this is largest when value is really small, which means that his health is really low. But that's not super important because we don't utilize that at all currently, but that's a really cool thing we have implemented, hopefully for the future. This is the actual image here. We're resizing it to be the height and width that we care about, downsizing it, of course. We're casting it to grayscale, and then we are saving it in this spot, overwriting it. If there's something there, we get the keys, we save the keys, and we save the rewards. If it's time to save this batch, we save them, of course, and reset the arrays. So the reason I'm saving this way is just so that if anything goes wrong or I cancel at any point, we can easily handle it. Also, if I just put them down at the keyboard interrupt so that when I'm done, I would have to actually go over and stop it. And additionally, like these won't save, right? If I cancel it halfway through, these won't save, which is good because the ending won't save then. And so we won't have like superfluous frames of you died or whatever. Additionally, if I put them down here, they might be huge files, depending, if I'm doing a Margit fight or maybe later I'm doing Elden Beast, right? And it takes me 10 minutes, 20 minutes to do the fight as like a wretch or something, then that's going to be a huge amount of data that you're trying to save in one file, which could be really slow or might not work or have some problems, and you don't want to lose that data. So that's basically the data scraping that we're doing. So if you want to play the game, and this might be something we sort of crowdsource, is getting a lot of supervised learning data, because that's something we'll get into probably next video, is how all this interacts. But the long story short is it doesn't really work because we don't have a lot of data, and the data we do have is coming from us, and I'm bad at the game. So if we actually wanted to work this, what we do is we'd set up here. You can see I have my little screen down here. So I'd run Python data collector. I should really fix that. And so then what we're going to do is we're going to run that and we're going to get a countdown. So I'm going to go into the mist. You can see an error because I didn't go into the mist fast enough. So now you can see it screen capping my everything. Yeah, that's the error because it couldn't find the health bar. So yeah, I'm just doing some damage. And then you can see I am quite Oh, and I just lagged out very hard there. I'm recording and playing the game is pretty slow. So now Alt Tab, you can see the frames per second that we're getting there. It's about 20. And then I'll actually go back and we can replay this. So I'll do Python. So this is now saved in the file test images. If I did this again, it would save in test images 1. So now I'm going to go to the test capture. So I'm going to go back to this. There we go. So this is the same sort of mapping here. And so what we're going to do here is read in our images and rewards and then go through them and play them. And so all we do is just show the image, get the keys, print the keys and the rewards, show the image. This is, I don't know why this is necessary, to be honest. This is just, this is what I saw in other people's code, so that's just why that's there. So now if I do that, I'm pretty sure I'm going to have to be quick about test capture. Yeah, so I'm going to want to add a window capture. There we go. You can see it's very small right now. I'm going to make it full screen and it's going to look really blurry. But that's what the AI is basically seeing. So if I do it again, hopefully this will work. Yeah, there we go. You can see a little bit of OBS Studio there. You can see I'm pressing W, I'm pressing A, that's D. The reward is messed up because I went in too late and so it didn't see it and so it thought it had no health. And anyway, so that's exactly what it's seeing right there, which is pretty cool. So that's making sure everything's working as expected. So now we can actually go into interacting with the game. And so the way we do that, and so you can see there's a little bit here that see some neural network code we'll get to in a little bit, is we use something called PyDirectInput, which is another package that I will, of course, provide, which uses, so I found a lot of problems. There's like keyboard, Python keyboard is very helpful for a lot of applications, but it doesn't quite work that well. PyAutoGUI also is pretty nice, but there's a lot of problems, I guess. I couldn't get it to work exactly, but PyDirectInput is very helpful. PyAutoGUI doesn't work in a lot of things with games because, for example, if you ever if you ever play the game, right, you'll see, do you want to use DirectX 12 or 11 or 13? That DirectX is how games read in inputs with as low latency as they do. And so they don't actually read it. Like if you use keyboard.press, which like simulates a key press, the game won't read it. And so if you do PyAutoGUI.press or whatever the function is, the game won't read it. Nothing will happen. And the reason is because the game is using this direct, I can't explain it well because I'm not like an expert on this, but basically to get as low latency connections and as fast sort of response as possible, the game doesn't go through the traditional channels. It has a special commands to actually interact more directly with the key presses. So you get really fast responses. So that's what PyDirectInput works. It works on DirectX. It's a great thing. So yeah, I won't belabor the point, but basically what we have here is a lot of neural network code that we're not going to get into. And then we just have our PyDirectInput here. This is something really weird that I found, is that there's a pause function or a pause option in key down, which means that if this is true, which is by default, there's a delay, like a 1 second delay between when you're allowed to press a key again, which is very odd. So you want to make sure this is set to false so you can get fast inputs. Other than that, this is the exact same thing. Basically what we're doing here is we're saying the neural network's outputting probabilities for pressing every key, because remember you can have every key down at the same time. And so if the probability is greater than 0.5, you're going to press the key down. Otherwise, you're going to press the key up. And so this does it. The reason we have it implemented this way is because if you did key down than key up, you don't really get, you get it like super jittery, and the game doesn't always read the input properly. So that's the reason we have this. And doing key down twice just continues to hold it down. Keep doing key up, if the key's already up, doesn't do anything. So this works really well. You'll notice that I set CUDA visible devices to -1. I'll get into that in the next video, but that's a fun little thing. So then the way we actually interact with the game is just by getting the predictions and pressing those keys. Here, I'm just going to replace this with the W key, I think is what it takes as input. Let me double check. Press keys vowels equals W for I P of 0 P of 0. Oh. Okay, so what it actually wants is 1 plus 0 times 10. There we go. So this is already read. And so this is just going to be W, or should just be W. So let me go back. I can also just comment this out. We don't need the neural network code right now. So now we can go back into the game. Let's go over here. Yeah, so let's go over here. Oh, run this way. And so what this should do, actually, I don't even need to go into the arena. What this should do when I press the Python run model, which isn't actually going to run the model, it should just send us forward. Unless I did something wrong. Oh, I did do something wrong. Okay, 1 second. All right, that should have fixed it. So now we'll go back over, get this up, and run this again. Go back over. I'm just clicking on it, and then hopefully, should really put the. Okay, well, I really need to. I copied this code earlier over from the files. So, okay, now this should work. Let's see, I'm running it again. Hopefully I'm not trolling right now. Oh my god, what am I? Okay, I'm gonna pause this and just debug this. I don't know what's going on right now. Okay, I think I know what the problem was. The problem was that I was trying to load. I was changing stuff about the model right before this video, and I was trying to load. Okay, now it should just go forward. Okay, oh my god, why does it keep happening? Okay, I'm just gonna pause it. Okay, I'll pause it till it works. Okay, it works. The problem was that I was, TensorFlow always outputs a two-dimensional thing, so I was indexing to 0, and then also I was loading the model, but the model had different sizes because it was an older model, but we won't get into that. So now if I do this, I do Python run model. Once again, this isn't running a model, it's just showing you how the direct input works. It's going to give you a bunch of code, it's going to do a countdown, and then it's going to tell you it's pressing W a lot. So, yep, and there we go. We can see that it is pressing W a lot. All right, so now we have established the basic input and output of the game. I can go back over here. Should probably get rid of that. And red here. And so now what we're going to do next time is talk about actually feeding this into a neural network. But that's the basic input and output of Elden Ring covered. Once again, we have the Discord server, we have the GitHub. So all this stuff, if you have questions you want to contribute, this is very much an open project.